All right, so Thursday today, which means tomorrow's Friday, which means tomorrow is a quiz day. Yes, indeed, too. Tomorrow is a quiz day. Okay? So, should have enough time to get some stuff done today. Get everything good was done. Okay? Yep. All right. So, all right, let's jump into it. So we're kind of going to be today on that supplemental sheet, but we're also going to be in your note packet too, because we do like the retrieval on page 18. Okay. So does knowing a person's shoe size? So there's the data set. Does tap the brakes. Does knowing, so we got to do some little correlation action, and then some classifying. Love it. Okay. All right. So what are we going to need? We're going to find a correlation coefficient. What do we got to have? Got to have your Chromebook because you got to have Desmos. Yep. Okay. What do you want to make as the X for this one? Shoe size. Okay. And what do you want to make as the Y? Number of siblings. Does it matter? Well, let's literally, before we do this, let's answer question number 2. Does knowing a person's shoe size determine how many siblings that they're going to have? No. Does knowing the number of siblings a person has, does that determine their shoe size? No. So does it matter which one you make X and which one you make Y? No, it really doesn't. Okay, right? But for purposes of today, just so that we stay kind of consistent, let's make shoe size be our X and number of siblings be our Y. Okay? So find me the correlation coefficient there. What do we get for a correlation coefficient? 0.9131? Yeah? Okay? Yeah? So, strong? Yes. But really, what's it strong about? Right? Okay? So that kind of leads into the next question here of why would using the data set provided possibly lead to incorrect conclusions? We got questions.
Well, I mean, they're related to the problem, but they're not related at all.
In like real life, right? Yeah, totally not related. So what conclusion are we really drawing? We do have a strong correlation, right? Our R value was 0.9131, right? But what's really being correlated here? You know? Nothing really, right? So that would probably not necessarily give us the right conclusion. You know, according to our data and our linear regression model, you know, if like, what am I? I'm a 10.5 shoe. Okay, so my shoe size is 10.5. I should have like almost 7 siblings. I got 1. Okay, actually just talked to her at lunch. Okay? You know what I mean? So it doesn't necessarily give us the proper conclusions. Okay? Love it. Number 4, linear, exponential, or neither? 1 in 3 shot. Linear, exponential, or neither? This is from first semester. Bringing it back. Number 4, linear, exponential, or neither? Why exponential?
Because it has like the exponent as x.
Because the exponent has the variable, right? Yep, so that makes it an exponential. Because the exponent is the variable is in the exponent. Okay? Number 5, linear, exponential, or neither. What? It is not linear. Why neither?
Because it's like, I only know because it got 6.
Okay. 6 is exponential?
Oh,
6 is linear because it's got an exponent of, what's the exponent on the variable? Say louder. It's 1, right? So linear ones have exponents that are 1. Exponentials have the variable in the exponent. Everything else is neither. Okay? All right? So this has an exponent of 2. Actually, it makes a parabola. It makes one of those U-looking things. Okay? All right? Love it. Next, supplemental sheet time. Okay? So we have 2 tables. We got a table on the front side. We got a table on the back side. I'm going to go through the front side with you right now. I'm going to walk us through it. We're going to talk a little bit about it, have a little discussion, and you guys are going to individually do the back side as practice. Okay? Got to have some good practice. Okay? So the 2 tables represent data regarding the total estimated deer population in Wisconsin, as well as the total deer harvest data from 2009 to 2023. Okay? We're going to use this data and Desmos to answer the questions that follow along. Okay? So question number 1 says, enter the estimated population. So we're on the front. Enter the estimated population data into Desmos to create a scatter plot. Okay? Now, what do we want to use 2009 as our X value, or do we want to use something different?
Maybe just, or we could do it
For which one?
2009.
So make 2009 be year 1?
Yeah.
Okay, because that would shrink up our data a little bit. Yeah. Okay. Do we want to do anything else to our data? You get the whole set of data on the screen here. Maybe there it is. Yep. Okay. So what's up?
Estimated population, 4-digit number, 4-digit numbers with 3 zeros, and then at the end you just add the group back.
Right? Okay. So how we can do that? Okay. So here's how you go about doing it. Both great ideas, because really a million, over a million, is kind of a big number, especially on a graph. Okay. I mean, likewise 2009, big number on the x-axis. Okay. So, Quest, you're saying that you want to make this be year number 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, then 13, then 14, and then 15, right? Okay, I'm okay with that. But then we have to add something to our data set. And then if we do that, and that's totally fine, then we would say the year since 2008, because that would be year 0. With me on that? Okay. Then what you were saying is we could just drop these last 3 zeros on all the way through. Yes? Okay? Right? And then we would say estimated population in the thousands. Because, so now we're saying that 1,160 thousands is 1,160,000. You understand what I'm saying there? Because that if we say that it's in the thousands, then we have to add those 3 zeros at the end. Oh, there is? Oh, so what should we do down there then?
0.5.
0.5. Yes, we would go 0.5 like that. And then we would still be in it. Yep. Good catch. Okay? Okay? So take some time now and some Desmos action. And let's put those in there in that table. Yes on this for your scatter plot? Okay. Remember to see it if we're discombobulated, I think I don't know if it'll do it. Yep. Okay. So if we're discombobulated and we want to see it, we can always hit that magnifying glass and it pops it right in for us. Okay. So now we want to create a linear regression for it. Okay. So there is our equation. I'm going to, okay. Good on that? So so my equation, or the equation I should say, is right here. And my R value, my correlation coefficient, is right there. Yes? Okay. All right, what's the next question? Question number 2 says, describe the strength and the direction of the correlation. Strong positive? Okay, I would concur that this would be a strong positive correlation. Okay, because we got a 0.91. Okay, what does the slope indicate? So first off, what is the slope of our line? What is the slope of our linear regression? So like 49,926, right? Okay, so we'll call it 49.927. Okay. What does that mean? Interpret that now. Years, each year. Okay. So on average, right? Because some years it went up, some years it went up a lot, some years it didn't go up as much, some years it went down, right? Okay. So that is the average increase I'm going to take that comma out. I don't want that comma in there. So the average increase is 49,927 deer per what? Per year. Yep, because we went by every year. Yep. So on average, that's how the deer population is growing. Okay. Our y-intercept in this case was 963.819. 963.819. Okay. What does that mean? You agree with her? But what was the actual amount of deer in 2008? Was it 800 or 963? Because we said, remember, because we switched it to our data is in the thousands, right? So we got to multiply that by 1,000. So in 2008, there were 963,819 deer in the state. Okay, so you're gonna multiply that by 1,000. Use your equation. So our equation was then, let me write this down here now. Our equation was y equals 49.927x plus 963.819. Okay, so that was our, oops, that breaks. So that was our equation. We want to perform the following predictions. What was the deer population in 2000? Well, am I going to input an X value or am I going to input a Y value? An X, okay. So in the year 2000, what is my X value? X equals -8? Like, what's my X value that I'm going to have to put in for the year 2000? No? -8? Because remember, we said year 0 was since 2008. Remember? Remember, we said since 2008. So the year 2000 would be the year -8. Right? Okay? All right? So I have to put in -8 into my equation. Y equals 49.927 times -8 plus 963.819. Probably going to need a calculator. $49.927 times -8 gets me that. Then plus 963.819 gets me, I get 564.403. Anybody verify those numbers? Yeah? Okay. So how many deer were in the state? What was the deer population? Get rid of the decimal point, right? Okay. What's my X value going to be for the year 2040? So now I'm going to plug in 32 into my equation, right? Okay, make it happen. But what do I gotta do with that? What? Multiply by 1,000. So then I get 2,561,483. Okay? Questions, comments, concerns, clarification? You answer the questions on the back side. So this is what I got for my equation and my R value. Yes? Okay. So strength and direction. Weak positive. Okay. Still going up, but very weak. As you can see by the scatter plot, it's all over the board. Right? Okay. All right. So I would definitely say that that would be a weak positive. What does the slope say that about the deer harvest? So what was our slope again? 1.823. So it's going up by, so on average, the harvest, there are 1,823 more deer harvested. Politically correct. Each year. Okay. Our y-intercept was 290.989. 290.989. Which means that there were 2,000 is going to be what again? What's my x value? -8. What does that every once in a while? Two, three, 290.8. Two, three, 290. Calculator. 1.823 I get here 276.405. So that means that they harvested 276,405 deer. Here I got 349.325, which means that they harvested 349,325. Yes? Love it. Quickly, let's take a peek at your homework. Make sure we know what we're talking about here, because there is a little bit. Number one is just a little bit confusing. Oops, that's line's the best fit. There it was. Okay. So in number one on page 19, okay, it's asking you here to find the vertical distance from the point to the line. So it's saying that the distance between point N and the line vertically right here is 3. Okay. Now, distances are always positive, so even if the point is on above the line, it's still, even if you're going down, it's still a distance, so it's still a positive distance. Okay? So it's asking you to find those, and then take those and find the total, find the average, etc. between all of those different ones and the line. Okay? All right? Then on page 20, okay, we're going to have you skip numbers 4 and 5. Okay, which I think is all of page 20. Okay. Okay. Then here's some more Desmos action, finding the correlation coefficient and the equation of the line of regression. Okay, so that's 6 and 7, and then talking about the slope and what does that mean in terms of the data set for number 6, and then for number 7 the same thing. Okay, good to go there. Then number 13, it's asking you which one of those best fits the data. That's a visual type, see which one best fits your data. Same with number 14. Okay. Number 15 is a thinking question. Is it always going to be a linear model? Could it be an exponential model? Okay. And then 16 through, I think it's like 20 something. 16 through 22, it's asking you if that scenario is linear, exponential, or neither. Okay? Any questions on the homework? It is lengthy in terms of pages. It's like 6 pages long, okay? But it's not lengthy in terms of work, okay? It's a pretty quick homework, so, okay?